This is lesson 932, problem 979. Okay, now we're still looking at graphing inequalities with two variables, but this time we no longer have a linear inequality. We've got y is less than x squared minus 4x plus 3. And so we know that this looks like a quadratic equation, but it's an inequality. So the first thing we can do is we have to graph our boundary line. So we have to figure out what would this parabola look like, and then we need to decide what side of the parabola to shade. Okay, so if I'm just looking at x squared minus 4x plus 3, I need to be able to sketch that parabola. All right, so that means I'm going to need to know what are my x-intercepts, what's my vertex, what is my y-intercept, okay? And so we just kind of want to just look at the equation. So let's just forget this is an inequality for a minute. And right away, I can find my y-intercept. And so hopefully you remember the shortcut for that. The y-intercept is where your x value equals 0. So it's just the number of ones in your equation when it's written in standard form. If you don't remember that, we need to let x equal 0. And then we will solve for y. So I'm just replacing all my x's with 0. And when I do that, everything goes away except for these 3. So the y-intercept, so this is the point, 0, 3. So my y-intercept is at 0, 3. So there it is. All right, then I need to take a look at my x-intercepts. So remember, we have 3 ways we could figure this out. Algebraically, so we could factor this equation to get those roots, or we can complete the square or use the quadratic formula. I'm going to factor it because I feel like these numbers look okay to me. They look nice and easy. They're not fractions or really big numbers, so I'm going to let y equal 0 because that's where we find the x-intercepts, is when y equals 0. And then I'm going to factor this. So generic rectangle and diamond. So hopefully we're getting really quick at this now. Our x squared terms go in the bottom left-hand corner, 1's in the top right. That makes the top of my diamond 3x squared. And then my x terms go in the bottom of my diamond. So I'm thinking about those factors that multiply to give me 3x squared and add up to give me negative 4x. So those would be negative 3x and negative 1x. Going to put those into my generic rectangle. And then my dimensions become x and x. X times negative 1 gives me that negative x. X times negative 3 gives me those negative 3x's. And then just to check, negative 1 times negative 3 does give me positive 3. All right, so now we've got in our factors x minus 3 times x minus 1, and we're setting it equal to 0. So we can use the 0 product property and find our x-intercepts. So solving for x, all right, we get that one of our intercepts, or our x-intercepts, at 3, 0, and the other one is at 1, 0. So these are our x-intercepts. And we had already graphed our y-intercept up here. Okay, so I'm going to go ahead and put those points on my graph. We have the point 3, 0 and 1, 0. Okay. And then I need to figure out where my vertex is at, and so these are pretty easy numbers, and you could probably work your way to the point right in between 1 and 3 and figure out the x-coordinate of your vertex. But if I didn't know that, if these were not nice numbers and I couldn't just do that, to find my vertex, go down here. Okay, I would just take my 2 roots, add them together, and divide by 2. And this is going to give me the x-coordinate of my vertex. So the x-coordinate of my vertex is at 2. Now to get the y-coordinate, I'm going to need to just take 2 and put it into my original equation and solve for y. So my equation was y equals x squared minus 4x plus 3. Yep. All right, so I know that the x coordinate of my vertex is at 2. So I'm going to replace my x's with 2 and solve for y. So I get y equals 2 squared is 4. Negative 4 times positive 2 gives me negative 8 plus 3. Simplifying, 4 minus 8 gives me negative 4 plus 3. And when I add those together, I get that the y coordinate is at negative 1. So I know my vertex is at 2, negative 1. Back all the way back up to my graph, over 2, down to negative 1. Okay, so now I've got those points and I can sketch this parabola. And so I'm going to go back and look at my inequality here. We have y is less than, right? Y is less than x squared minus 4x plus 3. So since there's no equal sign underneath that inequality, I know that this has to be a dotted line. It can't be solid because the points along the parabola do not make the inequality true. So it's either going to be the points above the parabola or below, and we'll test for that in a minute, but not the points on the parabola. Okay. All right, so now that we have our boundary line, we are going to go back to our inequality we started with, and we're going to test a point, okay? We only need to really test one point. You can test more than one to double check your work, but I'm going to rewrite this here. So I'm going back to my inequality that I started with. And remember, a good rule of thumb is the point 0, 0 is a great point to test because things will cancel out very easily. So I'm going to test the point 0, 0. So I'm going to replace x and y with 0 and see what I get. Okay, so I get that 0 is less than, so 0 squared is 0, negative 4 times 0 is 0, so those go away and I'm left with 3. So I get that the points, so I get 0 is less than 3. That's a true statement. So since it's a true statement and the point 0, 0 is below my parabola, I am going to shade in all of the points below my parabola. Oops, let me get a highlighter here. All the points underneath my parabola. Now, if the point 0, 0, when we substituted it into our inequality, if it was not a true statement, if we, when we simplified it down at the end, if that hadn't been a true statement, then we would have shaded in the opposite side of our parabola, the inside of our parabola, okay? But since 0, 0 was below the parabola, when we substituted that in, it made the inequality true. That means that all the points below the parabola, so the points that are so less than, below my parabola, are what will make the inequality true. Okay, and we have that dotted line because we don't have the equals to sign. So the points on the parabola will not make it true, just the points that are below the parabola.